Hi everyone, I'm Christina Howley. Thank you for joining me today as I discuss the results from the Cape York Water Quality Monitoring for the Great Barrier Reef Marine Monitoring Program for the 2019-2020 wet season. I manage the Cape York Water Quality Monitoring under subcontract James Cook University and work in partnership with James Cook, Australian Institute of Marine Science, and of course, GBRMPA. The water quality monitoring in Cape York is undertaken by a team of Cape York scientists, traditional owner ranger groups, conservation groups like the South Cape York catchments, and Queensland Parks and Wildlife Service. The partnership collaborates on a range of projects across Cape York, from freshwater wetlands out to the marine environment. In addition to the marine water quality monitoring, we have data loggers in 7 river estuaries. So we're able to document the sediment concentrations coming out of these rivers into the marine environments where we're monitoring for the MMP. I'd like to acknowledge the traditional owners on whose country I work in Cape York, and in particular, Yukubaja Muluku in the Annan River region, Rinyaru and Yintinga Aboriginal corporations in Princess Charlotte Bay and Stewart River region, and the Pasco family in the north. For the GBR Marine Monitoring Program, we have 4 subregions that we monitor in Cape York. These are adjacent to the Pasco River, the Stewart River, Norman B. and Kennedy Rivers in Princess Charlotte Bay, and the Annan and Endeavour Rivers in southern Cape York. We have transects in each of these subregions that we monitor from the mouth of the rivers out to the adjacent reefs and the open coastal and mid-shelf water bodies. We monitor each transect 4 to 6 times per year, primarily during the wet season. And we additionally do flood monitoring when there's flood events occurring, if we can get to those areas. We have just completed our 4th year of monitoring water quality in Cape York for the MMP. Why do we monitor for the MMP? Sorry, what do we monitor for the MMP? I'll refer you to an excellent presentation by Renee Gruber from Ames, and Renee goes into great detail about how and what we monitor for the MMP, so I won't go into that level of detail, but we do collect a whole range of samples, both from the surface and from 1 meter above the bottom at each of our sites. We analyze suspended sediment concentrations, a range of nutrients from particulate to dissolved inorganic and dissolved organic nitrogen and phosphorus, as well as carbon and silica fractions. We analyze chlorophyll A as an indicator of phytoplankton or algal densities, colored dissolved organic matter, and we measure Secchi depth as well. Finally, at each site, we measure temperature, conductivity, and salinity along a profile from the surface down to the bottom. In addition to the grab samples that we collect, we have 2 stations where we monitor continuous turbidity, chlorophyll A, salinity, and temperature. These sites are both located in the Annan and Endeavour region, and we have 1 data logger on Dawson Reef, about 6 kilometers from the mouth of the Annan River, and another data logger located on Forester Reef, about 40 kilometers away. Both of these sites are inundated during flood events. Obviously, the Dawson Reef gets more frequently inundated, but any of the medium to large size events tend to travel north and also inundate the Forester Reef site. So these data loggers really give us an excellent indication of when the flood events are inundating these reefs and the duration and water quality at the reefs during and after flood events. We can also tie that back in with the data loggers that we have in the estuaries for a number of sites with the Cape York Water Monitoring Partnership. Obviously, the logistics of working in Cape York can be quite difficult during the wet season. We luckily have a scientist, Lana Polglaze, who's based on the Pasco River with her boat support crew, and so they do the monitoring in that region. Our main operations base is here in Cooktown, and when we need to get up to the Stewart River and the Stewart River and Normanby River sampling, we travel by road from Cooktown. So we have to pack all of our field supplies, including an entire portable lab for filtering and processing samples, hundreds of bottles, and a whole range of eskies and refrigerators and freezers into our field vehicles to set up a portable field base, and as well as having to have everything else that we need to be self-sufficient for 3 to 5 days while we're conducting the monitoring. We travel up and set up camp at the Port Stewart Llama Llama Ranger Base, and sometimes at their field camp at Marina Plains. And we utilize their ranger boat, and their rangers provide field sampling assistance for the sampling that we do in that region. Of course, during the wet season, sometimes, quite frequently, the roads are inundated with floodwaters or simply washed out. And so there's no guarantee that we can actually get to these transects during the wet season. And so in those situations, we then have to go to plan B, which is to see if there are any boats that can get us up to do the sampling. And we have a network of charter boats that operate in Cape York waters, and they will let us know if they're passing by and happen to have space on the boat so that we can put a few of our team members on board to travel up and sample our transects all the way up the Cape. On occasion, we are also invited to join the QPWS Marine Parks Rangers on board the Reef Ranger, and that is quite a treat for us, since the vast majority of the time we're on very small boats where we struggle to even fit all of our equipment and eskies on board. So working on the Reef Ranger is quite the luxury. I was lucky enough to be the one who got to go on this past Reef Ranger trip in February 2020 with Tyrone Spratt from the Llama Llama Rangers. And the timing of this trip coincided with a bleaching event that was starting across the Great Barrier Reef. And so the Marine Parks Rangers were asked to focus on doing coral surveys. So while I was sampling, filling water bottles, they were out assessing coral health all the way from Lockhart River down to Cooktown. And they were also able to use some of my water monitoring equipment. So they had continuous temperature data loggers deployed on some of their boats, so that we had continuous temperature records all the way down the Cape, and they were able to take temperature depth profiles at each of the reef sites where they were monitoring. So it was really useful data that we were able to collaboratively collect and provide immediately to Gabrumpa about the amount of bleaching that was happening and the temperature in the water across the Cape. I was also able to convince the Marine Parks Rangers to conduct a reef survey and establish a monitoring site, coral monitoring site, at our turbidity data logger on Forester Reef. So that will be we'll be able to continue monitoring that into the future to see how any potential changes in coral health might correlate with changes in water quality. A big thank you to the whole Reef Ranger crew, who are just fantastic to work with. Why do we monitor? I will again refer back to Renee Gruber's presentation. She goes into great detail about how all of the different data that we are collected is used. In brief, we are collecting a long-term record of ambient water quality and documenting any potential changes into the future. We're also getting a better understanding of how flood events influence marine water quality and aquatic habitats. Why is it important that we monitor in Cape York? Well, the reefs in Cape York are considered to be in better condition than much of the rest of the Great Barrier Reef, and some of the risk assessments that are done say that Cape York region is a low priority, and it's therefore considered low priority for investments in improving water quality. But at the same time, there is a lot of evidence that the rates of erosion have increased by up to 10 times since the introduction of cattle over 150 years ago. And that translates to increased sediment loads in the rivers and discharged into the marine environment. despite the fact that large tracts of area, large areas across the Cape have been established as conservation land tenures, there is also increasing development pressure across the Cape, and that includes land clearing and agricultural expansion in the Normanby and Genie basins. There's extensive road erosion and new clearing being done for road erosion, for road construction. And this road erosion has been identified as one of the largest sources of anthropogenic sediment supplied to rivers in Cape York. Finally, we have a high frequency of intense dry season wildfires, and these late dry season fires have been shown to increase sediment loads and nutrients in adjacent rivers. So we know that we do have significant anthropogenic impacts on water quality in the rivers in Cape York, and these rivers are discharging their sediment and nutrients to the Great Barrier Reef marine zone. This is an image from March 2019, a MODIS satellite image of one of the larger flood events on record, showing the vast volumes of sediment being discharged from the Normanby Basin out into Princess Charlotte Bay and being transported hundreds of kilometers north, inundating extensive areas of coral reef and seagrass meadows. So it is really important that we're out there actually documenting how these flood events and how this anthropogenic sediment may be impacting on the marine environment in Cape York. Now getting into the nitty-gritty of the monitoring that we've been doing this past year. 2019-20 was a relatively dry year. We had below average annual discharge from almost all of Cape York rivers. This graph shows long-term river discharge in the Normanby Basin, and the red dotted line is the median annual discharge over the long term. Now you can see the red dot here at 2020 shows the annual discharge for this year, and it is below the long-term average. This compares to the previous year, 2018-2019, where annual discharge was about 3 times above the annual median. So we have gone from an extremely wet year into a below average, relatively dry year. Because there were no major floods across most of the Cape York rivers, our sampling primarily was done during ambient periods. We did manage to capture a few minor flood events in the Annan and Normanby rivers. And unfortunately, excuse me, we were unable to get out and sample during March because of the COVID travel restrictions. Luckily, in April, we were able to obtain permits to travel around the Cape, and with major adaptations to our methods and the numbers of people on our boats and the boats that we used, we were able to complete all of our sampling across the subregions in April. Now, looking at how the data that we collected compared with water quality guidelines, because we only have 4 years of data, we don't really look at long-term trends yet. So mostly we're looking at how does our data compare with the guidelines that have been established for Cape York. Because it was such a low discharge year, we found that most of the parameters we were monitoring were well below the guideline values. So here are some graphs showing suspended sediment concentrations, and on the left you have the Annan Endeavour transect and all of the ambient data in blue dots. And you can see the red lines show the Cape York water quality guidelines for the different water bodies, the enclosed coastal zone, the open coastal, and mid-shelf zone. And the majority of our data collected during ambient periods was below these guidelines. The exception was in the enclosed coastal zone for the Normanby and Kennedy. You can see these ambient data here in the enclosed coastal zone had very high suspended sediment concentrations, up to around 300 milligrams per liter. That's primarily due to wind resuspension of sediment in the shallow enclosed coastal zone. Now, looking at chlorophyll, we also found that the median chlorophyll concentrations across all of our subregions were below the guideline values. And that's demonstrated here with the data from the Norman B. Kennedy transect. The red lines again show the guideline values for the different water bodies, and you can see that the majority of our ambient data was below the water quality guidelines. The exception occurs during flood events when we get higher concentrations, but that's really to be expected. And most of the nutrient fractions also met the Cape York water quality guidelines. The exception, however, was the dissolved inorganic nitrogen and phosphorus, and these parameters exceeded the guideline values at almost all of our subregions and the different water bodies. This is most likely due to the fact that we are collecting most of our data during the wet season, and we're comparing wet season medians against guidelines that have been derived from annual data sets. So we're really biased to higher concentrations that can occur during the wet season. Now focusing in on our continuous turbidity data loggers, these graphs are showing the turbidity that was measured at the Anion Estuary, Dawson Reef, and Forester Reef. And the top graph shows river discharge from the Endeavour Basin. So the blue line is showing when we're having some minor flood events occurring in the rivers. And if you follow those flood peaks down to the Annan Estuary, you'll see that those flood peaks correspond to increases in turbidity. And during the flood events, we're getting turbidity ranging from about 300 to 500 in the Annan River Estuary. Traveling down to Dawson Reef, the third graph at the bottom, you can see that there is also a turbidity peak occurring during these flood events, and out at Dawson it's more like around 5 to 10 NTUs during the flood events. We do also get other increases in turbidity occurring out at Dawson that occur when there's not flood events happening, and those are also most likely related to wind resuspension of sediments. Finally, moving out to Forester Reef, about 40 kilometers off the coast. Because we didn't have any major flood events this year, we didn't see a lot of flood influence out at Forester Reef, with the exception of this second flood event that occurred, and we did get a peak up to about 7 NTUs turbidity out at Forester Reef during that event. How do these results compare with the results from previous years? Well, because it was such a dry year, the mean suspended sediment, nutrient, and chlorophyll A concentrations were all significantly lower than they were during the previous wet season, which had above average discharge. And this is demonstrated really well by the continuous data that we collected out at Dawson Reef, where you can see that the median wet season concentration for suspended sediment 2018 to 19 was 2.1 milligrams per liter. And if we move to this past year, 2019-20, that median wet season concentration dropped down to less than half of that at 0.73 milligrams per liter. Similarly, we had a chlorophyll A median wet season concentration of 0.35 micrograms per liter at Dawson Reef in 2018-19, and in this past wet season, that decreased down to 0.22 micrograms per liter. With these data loggers, we can also see the duration of impact from flood events, and we can calculate the number of days or the period of time that the water quality guidelines have been exceeded at the reefs. So in 2018-19, the chlorophyll A guidelines were exceeded over a period of 42 days. And in the 2019-20 period, that was down to just 16 days. I'd like to end my presentation with some words from Gavin Bassini, the chairman of the Yintinga Aboriginal Corporation, who is a great supporter and an integral part of our field team for the monitoring conducted at Princess Charlotte Bay. Hopefully you can hear what he's saying. It was raining in the background.
Hi there, my name's Gavin Bassini. I'm the Operations Manager of the Lama Lama Ranger Program based at Port Stewart. I'm also the Chair of the Inshore Aboriginal Corporation, and we manage and maintain sea country that actually starts at the mouth of the Massey River and then south to the southern bank of the Normanby River. Essentially, our camera takes in all of that area. Marine water quality sort of monitoring is something that's very important to us. We depend on our sea country for food and resources, and we'd like to keep it healthy as well for future generations. We support the water monitoring program with Dr. Christina Howley and her crew, and we work with them by providing boats, coxswains and rangers to go out with them to learn and to help keep our sea healthy.
Thank you to Gavin. And finally, I'd just like to acknowledge all of the many people and organizations who make this work possible across the Cape. As I mentioned, we have a team of Cape York scientists: Eric Dick, Jeff Shellberg, Lana Polglaze, myself and Jason Carroll. We also have the excellent field support from the Lama Lama Rangers, Yukubaja Muluku, Rinyur Aboriginal Corporation, South Cape York Catchments, and the Queensland Parks and Wildlife. Finally, we appreciate the assistance and the partnership that we have with James Cook University and AIMS, and we are always working together to ensure that our methods are consistent and that we're getting the best data quality that we can. Finally, to all of the boat operators and the Reef Ranger crew, a big thank you for keeping us safe out on the water. Thanks again for joining me.